A graph of the function y is equal to f of x is sketched on the axis below. The value of the integral from -1 to 1 of f of x squared minus 1 dx equals 1 over 4, 1 over 3, 3 over 5, or 2 over 3. So my first instinct here was to sort of figure out geometrically what this might be. I mean, we have to worry about the fact that we're transforming the x variable in a nonlinear way. In the integrand, we have x squared minus 1. But that might be a little bit messy, and I'm knowing myself, I'm probably prone to errors when it comes to doing that. So I thought that maybe another nice way of doing it would be to explicitly write out what the function f of x is. So f of x is, of course, just linear, piecewise linear everywhere. So there's simple expressions for what it's going to be equal to. And then, given an expression for f of x, it'll be easy to write what f of x squared minus 1 is. And that should be pretty simple. I'm going to do it that way, but maybe some kind of geometric argument might have been more straightforward. Okay, so there is the function f written out in piecewise linear form. I'm actually going to write, rather than f of x squared plus x squared minus 1, I'm going to write f of z squared minus 1 so that I don't mix up x's in one spot versus the other. Okay, so let me think a little bit about this. So this is clearly 0 when z is, well, what if it's the easiest way to do this. So when z is equal to 1, this is equal to 0, and we're kind of at the endpoint of these two intervals. As z increases, the input here, z squared minus 1, starts to lie in this interval. And when z is equal to the square root of 2, this is 2 minus 1 is 1, and so we're at that right endpoint. And so for z greater than square root of 2, we're outside of this interval. And I suppose that'll also be true for z less than or equal to negative the square root of 2. Okay, so now we only need to worry about z between negative root 2 and root 2. And I guess it's going to be a little bit weird because if z is between negative root 2 and negative 1, we're going to have one behavior. It'll be a similar behavior if z is between 1 and root 2. And it'll have a third behavior if z is between negative 1 and 1. Okay, this one might be the easiest to figure out. When z is between negative 1 and 1, this will be negative. And so we're concerned with this. Okay, so when this entire argument is negative, we're in this regime. We have to take the argument and add 1. And that's what we get as the value of the function. So it's just equal to z squared there. When this is positive, okay, and that happens when z is greater than 1 but less than root 2, okay, or you know, equivalently between the negative values of those numbers. The way we apply the function is it says take the argument, multiply it by -1, and then add 1. So I'm going to take this argument, z squared minus 1. I'm going to multiply it by -1 and then add 1. So this plus 1 becomes a plus 2. And that's our function. So now, oh, and as it turns out, the integral that we're trying to evaluate here, I should have paid attention to the question here as I was going through this. We're only integrating from -1 to 1. I'm only changing the dummy variable in the integral here compared to what's written in the question. So this is exactly the same thing as what we're being asked for. We only need to integrate from -1 to 1. This is equal to the integral from -1 to 1 of z squared dz. So this is, of course, just z cubed over 3 evaluated at -1 and 1. So this should be 2 over 3. I hope this is one of the answers. And it is. This is option D. Yeah, maybe this could have been done a lot more easily. This ended up being a little bit more complicated, tedious, and convoluted than I expected. You know, going through this was simple. That was very straightforward. But doing this was just, I mean, nothing terribly difficult, but maybe a couple different things to keep in mind at the same time. Once that was done, the integral was really easy. I should have paid attention to the fact that this is the only part of this function, this expression that I need. But yeah, maybe there's a much more straightforward way of seeing this one. Thanks for watching.